Hello everyone, today in this video we will know how to calculate the concrete and shuttering quantity of a square column. So here you can see the column. This is the length which is 300 mm and the width is given as 300 mm and the height of the column is that 2500 mm which is 2.5 meter. So to find the concrete volume required for these dimensions, we have to calculate by length into width into height. So the length is 300 mm, width is 300 mm into 2500 mm which is height. So 2.5 meter we can write. So after calculating this we will get 0.225 cubic meter of concrete volume is required for filling this concrete as per these dimensions. Now we will calculate how much shuttering quantity is required for these dimensions of a column. So shuttering quantity how we find by considering this perimeter. Perimeter means total all sides we have to add. So which is 2 into length plus width, which is this 300 plus 300 plus 300 plus 300 into height. This height is 2.5. So after calculating this we will get 1.2 meter, 1.2 and by multiplication of height if we do we will get 3 square meter of shuttering is required for these dimensions of a square column. So let us now calculate how much quantity of steel is required for these dimensions of a column. So here you can see the stirrup. So the stirrups are provided at which of 8 mm dia at 120 mm center to center spacing. So this is height which is 2500 mm. So here you can see the stirrup which is here we have provided 40 mm clear cover at all sides. These here to here you can see this is the 90 and this is our two bends which is at of 135 degrees and these three bends are at 90 degrees. So the length is 300 mm and the width is also 300 mm which we have no. So now we will deduct this 40 mm clear cover on both sides so that this 300 mm minus 40 if we do will get 220. So the size of stirrup will be 220 mm by 220 mm. So firstly we have to calculate cutting length of stirrup. So what we have to do, this 2 into this 220, two sides were there and again this 2 into 220, these two sides, plus here we have provided two bends which is of at 135 degrees. So we have to raise 2 into 90. For 135 degrees we have to take 90 for minus this 2 into 90, these two hooks were there which is of 90 minus we have to deduct the bend length. So two hooks we have provided at 135 degrees. So we have to write for 135 we take 3D. So minus 2 into 3D and there were 3 bends of 90 degrees. So 3 bends into 2D for 90 degree bend. So 2 into 220 which is 440 plus 2 into 220 440 plus 2 into 9 into here 8 mm we are taking. So when converting into meter we will get 0.008 meters. So minus 2 into 3 into dia again in converting to meters. So minus 3 into 2 into 0.008. So after calculating of all this we will get 928 mm or 0.928 meters. So let us now calculate the number of stirrups required. So total height by spacing plus 1 is the formula to calculate the number of stirrups. Here the total height is given as 2500 mm. Stirrups spacing is at 120 mm. So divided by 120 plus 1 we have to do. So that we will get 21.83. Approximately we are taking 22 numbers. So now we will calculate the unit weight. So d square by 162.2 is the formula. Here we are taking 8 mm dia. So 8 square by 162.2 we have to do. So we will get 0.394 kg per meter. So now we have to calculate the total weight of steel required for these stirrups for 2500 mm height. So the formula is cutting length into number of stirrups into unit weight we have to do. So cutting length we got is 0.928 meter and 22 numbers we require for 2500 mm height into the unit weight is 0.394 kg per meter. So after calculating all these three we will get 8.04 kgs of steel is required for these dimensions of a square column. So if you all like this video, please follow, like, share and subscribe to this channel. Thank you all.